probably not. We're going to be moving back and forth between the document camera and the slideshow here, and we're going to be talking about trigonometry, all of the things that we ever wanted to know. I'm going to put the attendance survey in the chat one more time. I think Zaylin, you just came in. If you'll fill out that attendance survey for me, please. All right, trig. I know you've heard this word, so it's been daunting. It is a little bit daunting, but that's okay. We're going to get through it. Trigonometry is the study of the relationships of side lengths and angles of right triangles. So keep that in mind, little bubble here. Only use trig functions with right triangles. There are proofs and theorems that go with trig functions and non-right triangles, but we're not learning that this year. We're only learning them with right triangles. So there are 6 functions of trigonometry: sine, cosine, tangent, secant, cosecant, and cotangent. Today we're going to focus on the top 3, sine, cosine, and tangent, and right next to it you can see are the shortened, abbreviated terms of these. So make sure you're writing these down: sine, cosine, and tangent. I'm going to give you a second. If you want to screenshot it, that's okay. There is a question at the end of our discussion in Canvas to answer, so make sure you're writing these down. All right, next slide. Tips for using trig functions. So if you're screenshotting or whatever, or writing these down, make sure you write this down. We're always, and you're not going to know what I'm talking about yet, and that's okay, but I want to make sure to get these on your paper before we start. Always start from the given angle. So if it says sine of A, that means start from angle A. Use trig functions when you need to find an angle from a given side, or if you need to find a side with a given angle. So keep in mind, you need to have 2 pieces of information in order to find the missing piece. Trig functions are always written as ratios or fractions, and trig functions are always written using the angle measure. So it's always in degrees. And if you don't know the angle measure or degree, then you're going to use a variable. And a great way to remember trig functions is SOHCAHTOA. It's kind of weird, but that's a good way to remember it, SOHCAHTOA. And we'll talk about what this means in just a second. So I'm going to give you a second to write that down. Brian, I saw you just hopped in. Good morning. I'm going to post the attendance survey one more time so you can fill that out. So write that down, SOHCAHTOA. It'll make sense in just a, oh, Brian, I'm so sorry. It'll make sense in just a little bit. All right, here we go. And I'm going on to the next slide. Here's our visual for trig functions. So if you notice, whenever we're writing trig functions, we're going to use a term called theta. Theta just means angle. So keep that in mind. Theta just means angle here. It's a Greek symbol. You know, they use a lot of Greek symbols in math. This is one of them. So our sine function, this is the SO. Our sine of theta equals opposite over hypotenuse. So this is the ratio that we were talking about. It's going to be written as a ratio. So sine of theta equals opposite over hypotenuse. Cosine, this is the and you can see it, sine is S-O-H here, those beginning letters. Cosine, C-A-H, the to help you remember that. Cosine of theta is adjacent over hypotenuse, and tangent of theta, this TOA, is opposite over adjacent. So I'm going to show you what this means. You can kind of see it with the colors here. if you're always starting at the angle that they give, here's theta, then the opposite value is going to be the opposite leg length here. And the adjacent value is going to be the leg that it shares the angle with. So it's right next door. So I like to think adjacent, like your next door neighbor is adjacent to you, right? It's next door. So the adjacent side is your next door neighbor. And your opposite side is like your across the street neighbor. So if they live across the street or across the hall, you have to go across the triangle. That's opposite side of the street. The hypotenuse is always across from the right angle, so keep that in mind. I know we talked about that a lot with right triangles. The same here. The hypotenuse is always across from your right angle or across the street from the right angle. So let's talk about what this actually means if we're applying it to our triangles. Are you good for me to move on to put up the different? Good? Did you write it down? Biggest thing to remember here is the SOHCAHTOA. That's going to help you remember what the ratios are. So sine equals opposite over hypotenuse. Cosine of angle equals adjacent over hypotenuse. TOA, tangent of angle equals opposite over adjacent. We're going to do some of these. All right, here's our notes. Here's our blank notes from today. So if you didn't print these out, this is okay. Just write them in your journal and you'll be totally fine. So your trig ratios, remember it's always written as a ratio or a fraction and it's always from the angle, okay? That's that SOHCAHTOA. SOHCAHTOA. Sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. Tangent of theta equals opposite over adjacent. All right. So let's do this. I'm going to color these using my highlighters. So it's going to help us a little bit. If you want to do this on yours, that's great. It'll probably help you remember. So let's start with our angle A. Okay, we're going to start with angle A. See, it says sine of A here. So the abbreviation of this is sine A, like this. They just get mushed together, sine A. So remember, our sine function is opposite over hypotenuse, right? So from A, the opposite value of A is this side here, A. Remember, it's across the street, opposite. So A over hypotenuse. My hypotenuse is always across from the right angle. So I'm going to highlight these just to help. So sine of A is opposite over hypotenuse. Oops, I think I was supposed to write that there. Opposite over hypotenuse. And then A over C is supposed to be here. It's first one, I already messed up. It's not good. All right, let's do the next one. We're still going to start with A. See, it says cosine of A. So my abbreviation is cosine of A. So we're going to start at the given angle. So my cosine definition is adjacent over hypotenuse, right? So I'm going to look from A, adjacent, next door neighbor is B. And my hypotenuse stays the same. It's C, always across from the right angle. So my ratio here from A, my adjacent is B. My hypotenuse is C. So right now we're just writing the ratios, okay? Later on, next class, we'll be solving and finding values. So let's look at the last one, tangent. Tangent of A. So again, we're starting with A value, our A angle. The tangent abbreviated is tan A, like that. So tangent is opposite over adjacent. So I'm going to think, okay, from A, the opposite value is side A, little a, and the adjacent value is side B, next door neighbor. So remember, opposite is across the street neighbor, adjacent is next door neighbor, shares a leg. So opposite over adjacent, we write the ratio as A divided by B, okay? A little bit crazy, a little bit okay, a little bit weird. It'll be a little bit better when we put some numbers to it, which we will in a second. All right, let's go down to the next one. It's sine of B. So we have a different angle here, right? So I'm going to start from B this time. So my abbreviation of sine of B is sine B, like that. My definition of sine, remember, is opposite over hypotenuse. It's a little bit different for B though, because B's across the street neighbor is little b over here. Different from sine of A, right? But hypotenuse always stays the same. Okay, so my across the street neighbor is B and my hypotenuse is C. All right, let's look at cosine of B. Abbreviated is cosine B. Let's look at our definition. Cosine is adjacent over hypotenuse. It's the c, right? C. So it's adjacent over hypotenuse. So let's look. It's going to be different than A because my next door neighbor for B is A, right? So next door neighbor is A. Hypotenuse stays the same. So my ratio here is A divided by C. All right, last one. And then I'm going to ask you a question in the chat, so be ready. We're going to do tangent of B. So abbreviated is tan B. So remember our definition is TOA, right? So it's opposite over adjacent. So let's get our highlighter out. From B, my across the street neighbor is little b, and my next door neighbor is A. So side B, side A. All right, so B divided by A is my ratio. So I want you to just take a look at these. We're not doing anything with them yet, but I just want you to notice, right? Look at the sine of A. It matches the ratio of the cosine of B, doesn't it? Isn't that funny? And then the cosine of A, adjacent over green over orange, matches the sine of B, green over orange. Kind of interesting. And look at their tangents. For tangent of A, it's yellow over green. For tangent of B, it's green over yellow. So a little bit interesting. All right, in the chat, tell me, what do you notice about the relationships here? What do you notice about the relationships of the sides and the angles? You can say one of the things that I said or something different. What do you notice about the relationships of the sides and angles? I'm going to write the question down here. I'm going to take a drink of coffee while y'all are typing. What do you notice? Ah, that's a really good point. I have a direct message that says there's not always an orange. That's very true. So for tangent, yeah, for either of the tangents, you're not going to use the hypotenuse. Good point. Very good point. What else? It doesn't have to be mathematical. It can be colored. It can be anything that you see here. Oh, that's a really good point too. Orange is never the numerator. Orange is always the denominator. Very good point. All right, let's move on and we're gonna try this out, okay? So we're gonna find sine A, cosine A, tangent A, sine B, cosine B, and tangent B. So I'm gonna create a little chart like we did in the last one because I know I'm gonna get confused if I don't do that. So I have 3 on each side, right? All right, so I'm gonna say, all right, this side is the one that starts with the A angle, and this side we're gonna start with the B angle. So I'm gonna do the same thing because I like to add color. If you do not add color to your life every once in a while, if you always write in black pen or, well, blue pen, I guess is a color, right? I encourage you, go get some colored pens, markers, pencils, highlighters. It just makes learning a little bit more interesting. All right, so my first one is A, right? I'm going to start from angle A. So remember, if I see sine A, cosine A, tangent A, I'm always starting from this angle. So here's my sine of A equals, so remember sine is so it's opposite over hypotenuse. So it's across the street neighbor and hypotenuse. So it's 5 divided by 13. Let's do cosine A. Ooh, let's color these first, just so we can be okay. All right, cosine A. So cosine is the ca, so ca, toa. It doesn't mean anything, it's just a good way to remember it. So cosine of A, starting with A, so I want next door neighbor, right? Adjacent is next door neighbor. And hypotenuse is always the same, 12 divided by 13. Yeah. 12 divided by 13. All right, now we have tangent, right? So ca toa. So tangent of A is opposite over adjacent. So across the street neighbor divided by next door neighbor. 5 divided by 12. Look at the colors there. Do you notice that sine, green, orange, or yellow, orange, green, orange, and then yellow, green? Isn't that funny? Yellow, orange, yellow, green. Interesting. All right, B is the same thing, but except we're going to start with sine B, cosine B, and tangent B. All right, so let's see. Sine of B, I'm going to start with my angle. Always start at your angle. By the way, you'll never have it from the right angle. It'll always be from the acute angles, okay? Sine of B, so sine is opposite over hypotenuse. So my across the street neighbor divided by my hypotenuse, 12 divided by 13. Noticing anything here as you're looking at them next to each other? Cosine of B is next door neighbor divided by hypotenuse, 5 divided by 13. And then tangent B, tangent or TOA, is opposite across the street neighbor divided by next door neighbor, 12 divided by 5. Oh, y'all, did you notice that I colored on the wrong one? Sorry about that. I knew I was gonna do that. If I held all the highlighters in my hand, I was gonna mess it up. Okay, go on and do example number 2. And then what we're gonna do is go to example 3. So this one's gonna be on your own. Now let's move down here to example 3 because I wanna make sure that we get to our assignments for today. Because really our assignment today is just doing the ratios, okay? So it says find each value using a calculator or a trig table, round to the nearest 10,000. So if you have your calculator, do I have a calculator? There it is. All right. If you have an iPhone calculator, it's right there when you turn it sideways. If you have an Android calculator, do you have an Android? Do you have an Android phone? How do you find your trig ratios? Same way, turn it sideways? Okay. Another way to do it, y'all, is to just go to our Desmos calculator because they have a calculator there too. So yeah, here we go. We can use Desmos as well. Let me make this smaller. All right, so our first one is cosine of 41. We're just gonna plug it in like this, cosine 41, that's it, 0.7547, that's our answer. And then sine of 78, we're just gonna plug it in and get it, 0.9781. All right, that's it. So that's all we're going to do today. We have some other examples that are here, except it's equations, and we're not going to do that today because trig functions are they're way different, right?